In Project 4, you're going to build an interpreter for the Scheme language. And this lecture is all about the structure of that interpreter. So how all of the important pieces fit together in order to achieve the result that we want, which is a program that's able to understand other programs. So here's the structure of an interpreter. It shares a lot with the calculator example that we looked at on Monday. There is an eval and an apply function. An eval evaluates primitive expressions. It also evaluates combined expressions, but when it finds one of those, then it calls apply to actually apply some procedure to some arguments. So these are both recursive. Here's how. The base cases of eval are for primitive values, such as numbers. It just returns that number. And for recursive calls that it makes, well, when it gets a combination, which is an operator and some operands, it has to evaluate that operator and evaluate those operands in order to get the pieces that you're going to apply. So recall that you apply the procedure, that's the value of the operator expression, to the arguments that are all the values of the operands. So how do you get those values? Well, you just call eval and you get them. And then it makes a call to apply. Now so far this doesn't look like a recursive call, but we'll find that it is. So we apply some procedure to its arguments. And that's all that we had to write for calculator. But I've left some gaps because we're going to add a few more pieces to eval. What about apply? Well, in the calculator example, everything was a base case. It just applied built-in primitive procedures, plus, minus, times, and divide. But we'd like to extend apply to be able to apply procedures that we define too. So here are the extensions that we'll talk about today. One is that there's a new base case for eval, where it will look up a value bound to a symbol. So we can define what symbols mean and look up what those mean in an environment. Another one is that we're going to evaluate sub-expressions of special forms. Special forms are things like if expressions that aren't the same as call expressions because they have a different semantics, a different evaluation procedure. But they have sub-expressions and those need to be evaluated, so you make recursive calls to eval. And then finally, we'll talk about how, in order to apply a user-defined procedure, we just evaluate its body. So that's calling eval on the body, where eval is up here. So eval calls apply in order to apply procedures. Apply calls eval in order to evaluate the body of those procedures. And thus we have two mutually recursive functions. And it's also the case that eval calls eval directly in several different instances. And both of these have base cases. So some new aspects that we'll see today are that eval is going to require an environment in order to handle its new base case of looking up a symbol. So the environment remembers what names mean. And how does that environment get constructed? Well, part of what apply does is it creates a new environment each time a user-defined procedure is applied. This is just the same as Python. Every time we call a function, we're creating a new environment. Here, every time we apply a procedure, we're creating a new environment. And that environment will be passed to eval so that when we look up a name, we get the right value for it.